Hello everybody, we are going to be making this sort of little Pong table tennis type game today, and it's really simple. It can be done in like about 150 lines worth of code. It's a two-player game, so I'm controlling both paddles at the moment, one with the keystrokes and then one with A and D, so you can make your first little two-player game, and it will keep track of the scores and stuff like that, as you guys can see. We're going to jump straight into that and have a little go at that right now. So the first thing to say is you need to make sure, just like everything else, that you're saving this in a folder with the assets you need. So you're going to need this ball PNG and you need the paddle PNG as well, and the background image as well. And obviously you can make your own balls and paddles and things like that. The ball is 10 pixels by 10 pixels and the paddle is 12 pixels by 64 pixels. So if you go onto like create pixel art online, you can make your own stuff from that. Okay, but just make sure that your Pong is saved in that folder or everything else. So the first things we're going to do, we're going to import Pygame and we're going to import system as well because we're going to be using these guys. Then we're going to, from Pygame, import, Pygame.locals, import all, so we're going to be able to use everything that we need. We're also going to need to use random, and we're also going to need to use time as well. We're going to initialize Pygame, and then we're going to set a couple of constants here. So our FPS, we're going to set that to 60. We're going to say our frame per sec is equal to pygame.time.clock. And then, because we're going to be drawing some stuff here, we're going to be like we're going to be writing some the scores and things like that. I'm just going to take the color white to start because I need white text. And then I'm going to set up the window. So window equals pygame dot display dot set underscore mode, and I want the window to be 500 wide by 600 tall, and then we'll fill it with our white. To be fair, I'm not sure we need to do that because we're going to actually put a background item on it, but we can get rid of that in a second if we need to anyway. I'm going to do pygame dot display dot set underscore caption. So this is going to be what appears at the top, and it's going to be Pong. Okay, so that's more or less our constant setup there, ready to go. We set a FPS, we've started the clock here, or we've said we're going to create a clock here, which is going to keep track for us. We've created the white color, which we're going to use to draw our fonts. We've opened up the window here, and we've filled it with white, and we've set a caption at the top. So the first thing we're going to program is actually the ball. So class ball, and it is going to be pygame.sprite. So our ball is going to inherit from our sprite, def init self. And I've said about this a couple of times in my other videos as well. I am using this code here to inherit. So I'm inheriting all of like the pre-built functions of Sprite here, and I'm using kind of super to allow myself to do that. So I'm inheriting all those pre-built functions. It's a little bit difficult to explain quickly, but it just means that I'll be able to actually use things which are already written in this Sprite class. If you want to find out more about how super works, have a little Google around because there's loads of good resources about it. So what I need to do first of all, I'm going to set the image of the ball, so pygame.image.load, and I want it to be that ball.png, which I put in the folder. And then I'm going to create a surface area for it, so self.surf. So this is like basically kind of like a rectangle I'm going to create where this image is going to be placed on. So pygame.surface, and I want this to be 10 by 10. Oh, I think I need a double bracket around that. Let's have a look. Because of the way surface takes that argument. And then self.rect. So I'm going to create a rectangle, and it's going to be of the shape of the surface shape. So I'm going to create a rectangle by doing self.surf.get_rect. And I'm going to say I want the center of this rectangle. So the rectangle I'm going to draw is going to be based on the size of the surface. So I've made a 10 by 10 surface. This rectangle is going to be 10 by 10. I'm going to say I want the center of this rectangle to be placed in the center of my screen. So when I was kind of mucking around with it, because of like the size of the shape and things like that, that comes out to about 250 by 295. I felt like that. You might want to tweak that, but I thought that because it should be half of this, 500 by 600, but I did feel like it was slightly too far over because the ball is 10 by 10, so it would be slightly too far over if it was 300. So this worked for me, but it may be worth you tweaking it. So this is just saying where the center of the ball is going to be. So I want the center of the ball to be in the center of the screen. And then we're going to select a velocity for it. So we're going to use this in a couple of ways. So obviously velocity is speed, and also, but we're going to use it to sort of like look at how fast the ball is going to go, but we'll also use it to kind of start a initial angle. So when the ball spawns in, it doesn't always go off in the same direction. We want it to kind of have a range of angles which it goes through. And we'll talk about how that works in a second. So there's our velocity. You can tweak these again, but this I found gives like a nice range of where it can kind of start and a speed and where it's going to kind of go to. But we will kind of have a look at that in a second. So that's the constructor set up for the ball and all of its attributes. So we can create our ball in a minute. So we now need to create a move function for it, and we want self.rect.x, so it's x and it's y basically. Okay, we're going to move them by the velocity given each time. So self.velocity 0, and then we're going to do the same again. So I'll explain this in a second. We'll do the same again for y, and that's going to be velocity 1. So what we're saying here is, here in our random here, say that these both have 1 and 1. It means that the x and the y will both keep adding 1 to each other. So if my velocity is set to this first position is 1 and the second position is 1 as well, here I will just continue to add 1 to the x and add 1 to the y to get that position and the movement across from the screen. If my velocity is selected differently, so say it selects 8 and 8, that's going to make it appear to be moving faster. So that's going to do like 8 plus 8 plus 8 plus 8. So if we take the first example, if these are both 1 and 1, in 3 movements, this would move 3 pixels. But if we take 8 and 8, in 3 movements, that's going to move 24 pixels. Okay, so that's how the speed kind of works from that point there. So what we're now going to do is we're going to work out the collisions. So we're going to make a function here, a method here, that works out whether or not we have collided with either side of the walls or above or below the paddles. And if we have collided above or below the paddles, we're going to adjust the score based on that. So we're going to do if self.rect.x is greater than 500. We are going to, so this is the x, it's going to be across the screen, so it's going to be on this right hand side of the screen here. We are basically going to make it go back the other way, and we're going to do that by looking at the velocity we stored at position 0. So if you remember, the velocity has got an x and a y. So we're going to take this x velocity and we are just going to basically invert it. So we're going to say equals minus self.velocity 0. And that will make the ball bounce off in the right direction, so it will bounce and it will continue going across its y, but then the x will be in the total opposite of where it's going, so we'll get that bounce on there. And we're going to do exactly the same for the other side of the screen as well, but this one is going to be if it's less than 0, we are going to do exactly the same again. So if it's less than 0, so if I'm going over the left hand side of the screen here, if I hit that left hand side of the screen, because that's going to be 0, I'm going to invert the velocity, so then I start bouncing and I go the other direction. It'll all make sense once we start actually using it. So now we're going to have a look at the top and the bottom of the screen. So again, we're going to look at the rect, but now we're going to be looking at the y. So this is going to be the top and the bottom parts of it. So the y is ever equal to minus 30. So I did this so it goes off the screen. So if we imagine 0 is the very top of the screen, minus 30 is just 30 pixels above it. So it's not tons, but it's just a little bit above it. So it goes right off the screen. So if it ever goes above the screen, we want to reset the ball to the middle of the screen, and we want it to be going the other. Well, I want it to be going the other direction. So if the top paddle loses a point, when it resets, it starts going towards the bottom paddle. That's just a little gameplay thing I thought worked quite well. You don't have to do that if you don't want, but we just do this exact same thing. So we set the velocity, but this time we're looking at position 1 because that's where we've stored our y velocity. And we then set the actual rectangles x and y to the middle of the screen again. So that's now going to go into the middle of the screen. We also, because here we're using that velocity as well to kind of get like the angle, so it's to do with the speed and the angle. If we don't set it again, the ball will always travel with the same speed and the same angle. So what we really want to do is every time the ball goes off the screen, we set a new speed and new angle for it, so the game's not exactly the same every single time. So we're going to reset to the middle of the screen, and then this will give it a new speed and a new angle. And we're going to do exactly the same again, but now we're just going to change this top bit here. You've probably guessed it. So this is going to be the bottom of the screen. So the bottom of my screen is 600. If the rectangle is ever greater than, and I had it set to 630, we're going to do the same again. So we're going to invert that velocity, and then we're going to set the x and y, so it's the middle of the screen, and we're going to choose a new velocity. One thing I did forget to say is that we are going to need to update the score. So I'm going to pass this as a list, and basically position 0 in the list is going to have player 1's score, and position 1 in the list is going to have player 2's score. And the indexing from 0 thing is going to make it a little bit complicated, but it's not too bad. So basically, if I go off the top of the screen, it means the player at the bottom of the screen has achieved a point, and if I go off the bottom of the screen, it means that the player at the top of the screen has achieved a point. So in order to do that, we're going to do score list 1, and we're going to increment that by 1. So that will be, if it goes off the top of the screen, it means player 2 would have made a point. And then here, if it goes off the bottom of the screen, it means that player 1 would have made a point. Okay? Hope that kind of makes sense. You'll see it working when we get going anyway. Then I need to I'm going to return that score list as well, because we're going to need to update like a global sort of score list variable for that as well. And that is my wall collision done. I'm just now going to make a quick draw function. So def draw, and just like any draw function, it needs to just take the surface to draw itself to. and then we're going to use the blit, so surface.blit, and what do I want to draw? Well, I want to draw the image, and on top of that I want to draw the rectangle, self.rect. So rather the rectangle is drawn and the image is drawn on top of the rectangle, and then this will govern how they move and how we reset them and all the rest of it. So that is the ball done. But what we're going to do right now is we're going to jump in and we're going to start making our player class. So we're going to do class player, and it's going to be a Pygame.sprite. And we're going to do exactly like we usually do, so def init, and it's going to be self x, y, and n. So our player takes the arguments that our player is going to need are an x and a y position and a number, whether or not they're player 1 or player 2, and then that will work out which keystrokes we need to listen for, because player 1 is going to have different keystrokes to player 2. Obviously, if we programmed it without this, when we move like the left and right keys, it would move both paddles, and we don't want that. So we need to pass it a whichever player number we are currently. Excuse me. So what we want to do is we want to inherit everything again. Oh, forgot the full stop. So that's going to let me use all the sprite class attributes and methods and things like that. And our paddle is going to have an image. You know, you could just draw these using rectangles. I tend to like kind of making them on like little sprite builders online, but you can just draw them using using like the built-in Pygame functions if you want to draw rectangles and stuff. But I quite like doing it this way. And then we're going to do the same again with self.surf to create a surface. So this is how big it's going to be. And my paddle is going to be 64 pixels long and 12 pixels wide. Then I'm going to create a rectangle, so self.rect, and it is going to be self.surf.getRect. And the center is going to be x, y. So the center of my let's check 1, 2. Center of my paddle is going to be based on the x and the y that I pass it. So basically, when I create this paddle, I'm going to say where I want it on the screen. So I'll pass an x and y here. When the surface is created, and then when the rectangle is created from that, we will work out where that will go on the screen based on the x and the y that's passed to it. So obviously, if my screen is 500 wide and 600 long, I would want the bottom paddle to spawn at 250, 600 to be down at the bottom. So 250 to be the middle of the screen and 600 to be at the bottom. And equally, for the top of the screen, we'd want it 250 and 0 to be at the top. But we might tweak that because we don't want it right at the top of the screen. Then the player number is going to be set to n, and we're going to have a score. So self.score, we're going to start with 0 for each player. Then we're going to have an update loop, so we're going to update the position. So we're going to do def update, and this is going to be looking at the keys which are being pressed. So pressed keys equals pygame.getKeyPress or .key.getPressed, and then so we've got the keys pressed. Now we need to only update the particular player, so we need to look at them. So if self.n, so if the player is equal to 1, that means it's player 1, and we're going to update using the left and right keys. So I'm going to do that. And then, again, I need to make sure that the paddle doesn't go off the side of the screen as well, so I'm going to do this. So if self.rect.left is greater than 0, so basically I don't want to be able to keep on going left, so the left hand side of the screen, the least amount on this is 0, so I don't want to keep on going left, so as if I'm at 0. So as long as I'm greater than 0 on this left hand side, the left hand side of the rectangle is greater than 0, I can keep going left. As soon as the left hand side of the rectangle is no longer greater than 0, I will not be able to press the left key anymore, because obviously I don't want to be going off the screen. So if that is the case, I need to check what keys have been pressed. So if pressed underscore keys is the same as key left, then I am going to do self.rect.move in place, move underscore IP, and I'm going to move it by -5. I don't want it to move up or down at all. Okay, so that's my left hand side, and I am going to do the same for the right. So again, it's going to be looking again for the player 1, so it will be within that first if statement. But now I'm going to do if self.rect.right is going to be as long as it's less than 500, because that is the right hand side of the screen, as long as that's less than 500, I want to move it, and then the key right, I'm going to move it by +5, because I'm going to keep on moving it to the right hand side of the screen. And that's it for player 1. And we just need to replicate this again for the second player. So it's exactly the same block of text, or block of code. We just need to look at player 2 now, so so if it's player 2, and then we just need to give it a different key. So I was doing with A and D, so lowercase a here and lowercase d here. So I've put in that lowercase a and lowercase d, and then that will let me control that player with A and D. So all I need to do now is define the draw function, and it's actually going to be exactly the same as this one here. So I'm just take the whole thing and put that there. It's quite repetitive, that draw function. We should really look at putting that into its own class and making like sort of like a rendering class or something, but it suits our purpose for the time being. Now we very quickly want to look at actually loading in a background. So again, you don't need to do this. Your thing would work without a background, but I like to kind of have a nice background loaded in as well. And they're quite simple to do as well, because all we need to do is kind of pass them an image and then load the image in. So it's not like it's a lot of work to get, just something that's a little bit nicer. So self.background image is going to be equal to pygame.image.load background image.png, and then self.rect. So we're going to make a rectangle of the size of background image, basically. So it's going to use that actual image. And then we're just going to set an x and y for it. So self.background x equals 0, self.background y equals 0 as well. So it actually puts it in the top left corner. So I'm just going to make a quick draw function for this as well now. So this draw function is actually slightly different in the fact that we need to do it, we're drawing it to the window. So we do window.blit, and then we're going to just pass it the self.background image, and then the x and the y as well. Self.background x, self.background y. And that's it, that's all the class is done. All we need to do now is make the main game loop for it, and the game will be ready to play. So underneath all this, we're going to start by loading the background. and then we're going to create player 1, and they, if we remember rightly, they need a position, so 225 20, and it's player 1. So I did so because it's it looks at the bottom, it looks at the left hand side. When it's drawing these rectangles, I found that 225, obviously because the middle of the screen would be 250, but 225 seems to get it more or less right where it should be. You can obviously tweak around these a little bit as well. So 225 there, 580, and that's player 2. So this is going to draw it in the middle of the screen at the bottom, and this guy's going to be drawn at the middle of the screen at the top. Then we are going to draw, create the ball. Ball equals my ball class, so I've created the ball there. And then we are going to put the players into a list because we're going to need to check our collisions with those. So player list equals player 1 and player 2. And we're also going to do a score list here as well. Equals, score list equals 0 and 0. The next bit is just adding in the fonts and loading in the fonts and things like that, so I'm going to do that very quickly. So those are the fonts loaded that we need. We might not need them all, but we've got them ready to go now. And now we just need to set up the main loop. So we're going to do while true. We're going to draw the background. And then we are going to render the two scores. So we're going to do player 1 score rendered. So basically, we're going to be continually checking on this this score, this player list score here, and then as that increases, we will draw it here. So we want the player 1's score to be drawn like this. So we say what font we want it to be, and we're going to render it, and we want, what do we want to be drawn? Well, we want the word score and then a space like that, plus a string version of score list position 0, because position 0 is going to be player 1's score, and we want that to be drawn in white. I had white all in capitals like that. And then we do exactly the same for player 2. So we're going to check to make sure that our user hasn't quit out of the game. So we're going to do for event in pygame.event.get. If they've quit, so if event.type is quit, we are going to exit Pygame, and we're going to exit, and we're going to exit the whole game. So if they click on the top right corner, we quit out of the game basically. Now we need to, so it's final part coming up here. So this is where we start drawing everything and checking for collisions and things like that. So we are going to call we're going to use the balls function, so ball.wall collision, and we're going to put in there the score list. So in our while loop, we're going to keep on going back up to this here, this wall collision, to check what's happening, and this will update our scores for us and all the rest of it. Now we need to check if the ball and the paddle have collided. So we're going to use the get collision built into Pygame for this. So pygame.sprite collide any. I'm going to look at the ball and the list of players. So this is why we've put our two players in a list, so we can check if the ball has collided with either of the items which are in that list. And if they have, it means that they need to bounce the other direction. So we just do that by inverting the velocity again. So ball.velocity and it's going to be the y, so it's going to be 1 because it's going up and down. That's the y-axis. We are going to just invert that, so it's going to be minus ball dot velocity 1 like that. So it goes up and down now once it hits that paddle. And now we are just going to draw everything. So we're going to do ball dot draw. We're going to draw that to the window. We are going to then move the ball. Cool. Then we are going to look at the player 1's position. So we're going to update their position, and we're going to do the same for player 2. And we need to draw both of these as well. One dot draw. That should be a capital P. Player 2 dot draw. Both of these need to be drawn to the window. And then we are going to blit our rendered score to the actual screen as well. So we do window.blit, and it's going to be P1, player 1, score rendered. And we just need to say where that's going. So for the first player, I put it in 10, 10, so it's in the top left corner, as they are player 1. And then we do exactly the same for player 2's score, and we put that in the bottom. I put it in the bottom left corner. So 10, 550. Then we update the display. Then we tick the clock, frame per sec dot tick FPS, and if we've done all that correctly, our game should now run. So fingers crossed. Let's have a little look. Oh, so in the player here, I just forgot those 2 underscores to be able to correctly inherit using the super. So let's try and run it again. Oh, I see exactly what I've done. When I've created the background, I didn't actually use the thing at all. So background equals, I needed to actually write the class in here. Going too quickly and I made a mistake. It's actually background equals and then the class name. So let's see if this is going to work. So that should be player list. So again, player list. So down here in our main, in our sort of main loop here, kind of getting through these errors now. So that one should be player list. So that is the last error, and we can see here that is it's looking pretty good. It's just collided with both the paddles. So let's let it go off screen there. Oh, and it's collided with that second paddle there, and it's looking like it is working pretty well, I think, actually. So we can see there the way it's resetting. It's actually resetting at a different angle each time, a different speed as well. You can see the scores are both keeping track, and I'm controlling both paddles, one with the left and right key, and one with the A and D key. So I hope you like that. Nice little tutorial. So make your own sort of like Pong type game in about kind of like 20 minutes and have it a little like 2-player type thing.